S. Chan presents educational video lectures as per the new UGC curriculum. Difficult concepts made easy. Study anywhere, anytime.
Annuity is one of the term which is often confused with interest, and majority of the people think that annuity is similar to the interest value, but there is a big difference between annuity and interest values. So let's have a look at this concept, and we'll have to find out certain values of annuity with the help of certain numerical problems.
If you want to study this topic in detail, refer to these books from S. Chan Publishing and Vikas Publishing House. Link is provided in the description box.
Welcome to S. Chand Academy, and I am Anmol Bhatia. We are doing the course Business Mathematics. We will be covering a topic which is annuities. So what is annuity basically? Annuity is basically a series of payments which is to be made at a successful intervals of time, and that particular series of payments is called as annuity. And that is different from compound interest. Compound interest is a set of value which is being calculated for a specific period, but here we have the recurring values which is being calculated for a particular set, and that amount is there linked with successive payments. Usually these payments which are termed as annuity payments, these payments are identical, and that particular payment set is called as the level or uniform annuity. We have certain classifications or categories of annuities, like we have immediate annuity, we have annuity due, we have annuity certain, life annuity, we have contingent annuity, and we have perpetual annuity or perpetuity. So immediate annuity is basically paid at the end of each period, and that particular set is called as the immediate annuity. Let's say if you have taken certain amount, and you have to pay that amount value which is including the principal value, so that you end up with your dues, that particular amount value which is including that interest, and you are paying it for a particular period of time, that particular value is called as immediate annuity. Annuity due is basically it's linked with the payments that are made at the beginning of each period, and that particular thing is called as annuity due. So let's say if you are paying the amount at the end of a particular period, that particular thing is linked with annuity which is immediate, and if you are paying that amount at the beginning of a particular period, that particular thing is called as annuity due. And you are paying that amount the total number of times, and that particular total times is fixed, that is called as annuity certain. That means you have a fixed number of payments that are being given to a particular person whom you have borrowed that particular amount. And life annuity is basically linked to the term in which the payments are to be made as long as the person is alive, and that particular thing is called as life annuity. Maybe a particular set in which you have to pay that particular person up to a certain period of time, and that particular thing maybe is linked to a plan that is being taken by a person, and that plan is still the link to the life insurance, or let's say another set in which the person is paying that particular amount till a period when till the person is alive. Then you have a contingent annuity. Contingent annuity is the annuity with the number of payments which are depending upon the number of events which are happening. So let's say if at a period of time one person wants to pay a particular amount, that can be paid, and in the next set he can skip that particular amount that is required to be paid, and maybe in the third set that first and second or the other amounts which are left, that can be combined and paid in one go. That can be related to the contingent annuity case. And perpetual annuity is that particular annuity that is supposed to go on perpetually or endlessly. So depending upon the requirements that is there. So if you want to carry out or you want to carry those payments again and again, so without any end, so that particular aspect is related to the perpetual annuity or perpetuity. So the thing is, how do we calculate those accumulated values in terms of annuity calculations, and what is the final amount that is being given to a particular person after this calculation? So we have this annuity calculation, which is somewhat similar to the compound interest formula, and that particular aspect is related to compound interest rate only. So here we will be dealing with the compound interest rates and use those compound interest rates in terms of annuity calculation. That's why in terms of certain universities, when the syllabus part is mentioned, so the majority of the universities mention that compound interest and annuity similarly, or they go hand in hand. That means this compound interest is related particularly with annuity or accumulated value calculations. So here you have the accumulated value of an immediate annuity, which is of rupees C, that is required to be calculated. So here, if I need to find out this accumulated annuity, accumulated value of this immediate annuity, that accumulated value would be equal to C times 1 plus I raised to the power n minus 1 over I, where I indicates a particular set which is related to your compound interest rate value, which probably in percentages is there. So we just look at that particular annuity calculation or accumulated value calculation with the help of a particular set of question. Let's say it is mentioned that one person deposited rupees 10,000 at the end of every year in a bank, offering a compound interest at 8% per annum. And what would be the accumulated sum after 5 years? And that person is not withdrawing that particular amount from the bank. So that particular amount is termed as the annuity value calculation, that annuity value. So here you have that C value which is given, and that C value is 10,000, and rate of interest is mentioned as 8%, and you need to find out what would be the accumulated value. So you have the particular statement, and you need to convert that statement into the symbols. So you have the annuity value, which is C, that is mentioned 10,000, and number of years are mentioned, rate of interest is also mentioned. Here you need to find out the I value. So I is rate of interest divided by 100. So that would be 8 divided by 100. That means you will get this value of 0.08. So you need to find out the accumulated value. That would be C into 1 plus I raised to the power n minus 1 over I. So I here is rate over 100. That means you have the value of 0.08. So substitute that value of 0.08 here, number in the same set of equations, divided by the same. So on solving with the help of the calculator, you will get this value 58666. That means if any person has deposited this amount and the bank is offering a rate of 8%. So after a set period of 5 years, the amount would be accumulated to this particular value. Here there is no requirement, or the question is not asking for calculating the compound interest, or the question is not asking for calculating the value of the amount. The question is basically asking for the accumulated value, how much amount will be accumulated in that particular person's account after a set of that particular period. So that means you need to find out the annuity calculations in terms of finding the particular accumulated value. So this is the basic calculation behind the final accumulated value that might be there in the account of that person. Now the second question is related to the recurring deposit or the recurring accounts. You might have heard about the different types of accounts available in the banks, like you have a fixed deposit account, you have a recurring deposit accounts. So this is the case of a recurring deposit accounts in which the annuity calculation comes into picture. and the rate of interest is compounded in terms of the compound interest values. So here the question says that Anish opened a recurring deposit account in a bank for 4 years, and that particular period of time, the payments he has made is 5,000. It is being paid at the end of every year. So he pays 5,000 at the end of every year, and we are supposed to find out the money he will get at the end of the period of 6%. So you know that the banks generally do the calculations based on the compound interest values, but the accumulated value is to be calculated as the annuity. So here annuity value is mentioned to us as 5,000. That means a person deposits in the bank a fixed value which is 5,000, and the person generally gives this value at the end of every year, and the number of terms is mentioned, 4, rate of interest is also mentioned, and I is required to be calculated. So I is rate of interest divided by 100. That means you have rate as 6 divided by 100, so it will lead to a calculation set which is 0.06. So you have the accumulated value which is C1 plus I raised to the power n minus 1 over I. So I value is 0.06, so you need to substitute that I here. So 0.06 raised to the power 4 minus 1. On solving, you will get this value, which is 21873. So calculator is allowed. Generally, you can do the specific set of calculations and go with the results. So you can see that 5,000 was deposited in the account. After 4 years, the person is getting a final value in the recurring deposit account as 21873. So this is as far as the rate is concerned, that rate was 6% and the time period that was there is 4 years. So that means the person might have deposited 20,000 in the bank, and he is getting an interest of 1,873. That means accumulated value is calculated in one go. Now we have another set of question, and the question says that if I want to have an accumulated value of, let's say, this much amount, so how much is my calculation, or how much should I add into the account? Let's say nowadays there is a majority of calculations or majority of the sayings that you go with the SIP or a systematic investment plans. And in that systematic investment plans, there is a specific goal of a particular customer that I want to have, let's say, 1 crore value at the end of this particular year. I need to have my savings of 1 crore. So how much is the amount that I should save in a particular year, so that I'll get a particular accumulated value? So this question is somewhat similar to that particular aspect only, in which the account is a recurring account and you need to find out what would be the case of the annuity calculations, and if it is mentioned that you have the accumulated value with you. So you can see that the question says that what sum should be set aside at the end of each year for 4 years. That means a person wants to do a yearly saving for, let's say, 4 years at the rate of 10%, which is compounded with the help of this compound interest, to replace the machinery which is expected to cost rupees this amount at that particular time. So whenever after 4 years it is mentioned that this machinery that the person wants to purchase is having an amount of this much, and he wants to earn this amount of money, so the person is looking for the principal value that is to be given to the bank, so that he may get the accumulated value of this amount. So we'll have that particular set of calculations. We can use this accumulated value as given in the question, and the number of years are also mentioned, rate is also mentioned, and we have to find out I, which is rate over 100. So rate is 10%, so 10 divided by 100 is that much value, and I need to find out what is the annuity that I need to pay to the bank yearly. So accumulated value is mentioned, so you can substitute this value here, and C part is required. 1 plus I is 0.1 raised to the power n is 4 minus 1 over 0.1. So with the help of the simple basic arithmetic calculations, you can easily find out what would be the value of C. So you can get the value of C no doubt with the help of this mathematical calculations. And if you can have a target set to go with your savings, so you can also do these basic calculations and find out what would be the value of the amount that is to be submitted, so that one can easily earn this particular amount after a period of time. Another example, like what amount should be deposited at the end of each year for 4 years so as to receive a one-time maturity of rupees this much at a rate of 10% compounded yearly. This is the same set of question in which you are having the accumulated value here and C is required. So rate of interest can be substituted here and you can easily find out the value of C. Another question says that what amount should be deposited at the end of each year for 4 years so as to receive a one-time maturity of this. So we stop here for a short break. After coming back from the break, we'll learn the concept of annuities more in detail.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on UGC curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting within the comfort of your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy after the break. Before going to the break, we have learned the concept of annuities. We have learned different types of annuities, and we have seen that there is a particular formula for an accumulated value. And that accumulated value is generally for a set of a particular year, let's say for 4 years or let's say for 3 years or 5 years. But nowadays, these banks are giving flexible recurring deposit accounts. Let's say the banks are giving flexi RDs, flexible recurring deposit amounts, in which the person has a flexibility of withdrawing that particular amount for, let's say, after 1 year, or withdrawing that particular amount for, let's say, 2 years or 3 years. It do not have a fixed set of value. That means you have to keep that amount, let's say, for 4 years, or you have to keep that amount in the bank for 5 years. We have no doubt that particular schemes, but in order to attract the set of customers, the banks are offering those flexi recurring accounts. So if one wants to have the present value of that annuity, let's say for after 6 months, or let's say after 1 year, so what would be the present value if I withdraw my money? So that particular set is related to a particular formula, and we will be discussing that particular aspect here in this video. So the thing that I was talking about was a present value of that annuity. So the present value of the annuity is given by the same formula, but the denominator part is somewhat different. So present value is connected to this annuity, which is C. So it is 1 plus I raised to the power n minus 1 over I into 1 plus I raised to the power n. This is the formula being used to find out the present value of the annuities. Let's say we have to find out the present worth of the annuity. And the present worth of the annuity, if I want to find out for, let's say, 25,000 per year for 3 years at a rate of 9%, and the person wants to have the present value. What would be the present value of that particular annuity? So for present value, you have that particular formula that I have told you, and that formula is present value is C 1 plus I raised to the power n minus 1 over I into 1 plus I raised to the power n. So the first and the foremost thing is to convert the particular statement into the form of symbol. So we have to convert it in terms of symbols, like we have the value of annuity as 25,000. So you can substitute the value of C as 25,000. The number of years are mentioned 3 and the rate of interest is 9%. So from that R value you can find out the I value, and putting everything in the formula you will get the present value of the annuity. So if it is mentioned 9% rate of interest and 3 years is the particular set, and you need to check that after 3 years what would be my present value of the annuity. So it would be this value. You can have that simple set of calculations. After putting in these values, you can find out the final results. Another question, and the question says that what amount should be deposited in the bank so as to receive 15,000 at the end of every year over a period of 4 years at the rate of 14%, which is compounded yearly. So the person is asking that what amount should be deposited in the bank so that I may receive this 15,000 at the end of every year. That means the person wants to have a particular set of you can say set of source of income is required by that particular bank. You have seen that many post offices are offering this particular type of scheme, in which you name that those schemes as monthly income plans, in which the post office generally asks the person to deposit a particular set of amount for, let's say, 4 years, or let's say a particular period of time. And after every year, the post office is giving you a particular amount, and that amount can be broken up monthly, or the amount can be withdrawn yearly from that particular post office. So if you withdraw that particular amount monthly, that would be called as a monthly income, and that monthly income is from that particular amount that is being deposited in the bank or in the post office. So this is a similar question, and one wants to have this 15,000 to be received from the bank at the end of every year, and the person has deposited this amount at a rate of 14% for 4 years, and he wanted to know that how much amount shall I deposit in the bank so as to receive this particular set from the particular bank. So for that we have this present value of this annuity calculation, and this present value of the annuity is related to the formula, which is C1 plus I raised to the power n minus 1 over I into 1 plus I raised to the power n. So it is mentioned that rate of interest is 14%. So R is 14 and I value is rate over 100. So I can substitute this R as 14 over 100, and I'll get this value 0.14. So when I substitute it here, I'll get the value of 1.14 raised to the power 4 minus 1, and present value is required. So present value I can no doubt substitute here, so that to receive this particular amount I need to pay, or I need to fix in this particular value in the bank for 4 years so as to receive that particular amount. No doubt the rate of interest is very high, that's why this amount that is being deposited is on the lesser side. The other question, or the other set of the statement says that what is the present value of the series of cash flow of 50,000 per year for 4 years that is there with a particular company, and that has a rate which is 8%, and that rate is compounded annually. So the one thing that we want to know is finding out the value of the present value, because the question says that what would be the present value of the series of cash flows. Series of cash flows means that we are depositing, or we are adding the particular value which is 50,000 in our accounts for a particular year entry. So this is per year entry in that particular account, and we are entering that particular amount into our accounts for 4 years. So I need to find out the present value. So it is related to the same set of the problem, in which you have the annuity value which is 50,000, the number of years are mentioned, rate is also mentioned. So finding out this interest in terms of rate, which is R divided by 100. So on solving it, I'll get a particular value. So principal or the present value is mentioned, which is C1 plus I raised to the power n minus 1 over I into 1 plus I raised to the power n. After substituting these terms here, you can easily find out the value of the present value of this cash flow. Now, the other aspect that is there with this annuity calculation is the EMIs. So, you must have seen that majority of the banks nowadays are offering these home loans or loan against property values. And in that particular set, the customer is keen to know that what would be my EMI if I take a particular amount of, let's say, 40 lakhs or let's say 50 lakhs from you, and what EMI I need to pay. Nowadays, it is very simple. You need to just enter those values with the rate which is being offered by the bank in a particular software, or let's say in Google, and you'll get that EMI calculations. But what is the back-end operation, or what is the back-end operation in that particular application or the software? We need to understand it before going with the EMI calculation. So EMI is basically the equal monthly installments that is being taken from the customer by the bank when the bank offers a particular set of loan to the customer. So as you can see, that loan taken from any financial institution is to be repaid by equal monthly installments. So there are two methods. One is the reducing balance method, in which you have to return that particular amount in a particular fashion. And the second is flat interest rate method. That means the bank is offering you a flat rate which might be fixed for a particular period of time, let's say 8-9%. And that particular fixed rate is being governed by RBI, and the bank generally charge particular set extra as a kind of fees, so that would give you a particular value. So here also you can use that same formula of this present value, which is C1 plus I raised to the power n minus 1 over I into 1 plus I raised to the power n. That would be helpful in the EMI calculations, which is related to the annuity aspect. Let's say you have a person who has taken a loan of 80,000 from a bank for a period of 2 years, and 12% is the case, and you need to find out the EMIs using the reducing balance method. So what is to be done? You can say that this present value is 80,000. That means the loan is to be taken from the bank, which is the present value. That means I have taken an amount of 80,000 from the bank, and for the period of 2 years, so n is 2 years and rate of interest is 12%. So I need to find out I is R over 100, that means 0.12, and from here I need to find out the C part. So n here is 2, so 2 multiplied by 12, that means it is to be converted into months, so 24 months. And rate of interest is 12%. So 12% is to be converted into I in terms of I. So I is 0.12 divided by 12. So this is the case of you putting the value of this I here. So 12% is already this I value, which is 12 divided by 100. So 0.12 is the case. So 0.12 divided by 12, because I need to find out equal monthly installments. So here I is 0.01, which is to be substituted here, and raised to the power 24 minus 1 over 0.01 into 1 plus 0.01 raised to the power 24. So this is the 80,000 present value, and C would be that equal monthly installment that would be taken or charged from that particular customer. So in the previous times, when it has a manual situation in which a person takes a loan, and there is a general tendency of the person asking for the number of tenures. Let's say if I am taking a loan from the bank, I generally ask that particular amount, that what would be my EMI after 3 years. So I'll get a particular value, and that particular value is required is calculated through a particular set of equations which is there. But the thing is, you have to divide that particular rate and time in terms of months, because you need to find out equal monthly installments for that. So here you put in the value and find out the value of C. So we'll get this value of 3765. So 3765 is the monthly amount that you will be paying to the bank, so as to get a final value which is the present value of 80,000. So depending upon the rate which is being offered, you can calculate that particular amount easily. Another same question, that the amount of 30,000 is to be returned in 4 monthly installments at the rate of 12%, and that is compounded monthly. And what would be the EMI? Use this reducing balance method for the particular sake. So for that, I have this present value which is 30,000, n is 4 months, rate of interest is 12, and I is R by 100. So that means I is 0.12. I need to find out what is the value of C. So present value is mentioned 30,000, C is to be calculated, and the same formula is there, which is 1 plus I raised to the power n minus 1 over I into 1 plus I raised to the power n. So on solving, I'll get a value of 7688. That means finally I'll get, I have to pay this particular amount of EMI to the bank when I receive that particular amount, which is 30,000. You can calculate that particular thing, but this amount is to be returned in four monthly installments. So that amount is to be returned in that 4 monthly installment, keeping the rate of interest also in mind. Now another question is a similar type of question in which you have this amount which is 4 lakh that is to be taken from the bank for a period of 4 years, and you need to find out the EMI and using 6% FRR, which is the flat rate of interest. So if I have this flat rate of interest, what happens? I need to find out the principal. I have this principal value. I have this number of years mentioned, 4 years, and rate of interest is also mentioned. So flat rate of interest means you have to use this simple interest calculation in terms of calculating this EMIs. So in the previous cases, we have seen that we have used the compound interest formulas basically to find out these calculations. So simple interest is to be calculated, which is principal into rate into time, which is this amount, which is 4 lakh multiplied by 4 years multiplied by the rate over 100. So I'll get this 96,000 as my simple interest. I'll add this simple interest into the principal value. I'll get this value, which is 4 lakh 96,000. So EMI is when I divide this particular amount into the number of periods. That number of period was 4 years. So I need to convert that into months. So 4 into 12, I'll get this value of 10,333.33 as my EMI. So with this, we come to the end of this video, in which we have learnt about the cases of EMI calculations, and also we have seen the different aspects of annuity calculations. Thank you.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.